So we can get into maybe some analog I/O now. We'll do analog in to start, I guess. I have a joystick over here that we can use. XY joystick with a select button. Obviously the X and Y readings are going to be analog readings, so it's going to give some type of voltage based on where the joystick is, and we can read that in to kind of figure out what position the joystick's in. So you could do pretty easily, let's say joystick, X equals analog pin, that's not how you do it, analog pin 0. So that would be our X. And this is different too, because before, in the old API, you would kind of just use your ADCs, and you'd only had a limited number of them. We've multiplexed them out now, and we just have general purpose analog pins if you're just trying to do stuff like this. So you can use a number of analog pins instead of just a couple ADCs. So we can just do it like this, analog pin 1. And now those ones are all set to go. We have a select button too, so we'll use that. So select equals, make it a digital pin. I think it's connected to 12.0. And now for this one, you have to check your joystick's pinout, I guess, to figure out how you want to configure this. This one shorts to ground when you click it. So normally what you would do in that situation is you would make it an input, and you would set up a little pull-up resistor so that you would rate it high so that it would pull up to high until you shorted it, and then it would register that it's ground. But we actually can just do pull-up like this, and that should work without having to actually set up a pull-up resistor. So we can just connect it right to the pin and just configure it as pull-up, and that should do it. And then of course, because it's pull-up, you want to make sure it's high to start, and then that means it'll stay high until it's clicked. So if you read it, you see that's true, but if you click it, it'll be false. So now we can do something like, let's say while select.read. So while the button's not pressed, let's print joystick x dot read volts. So that will be that you'll be reading the voltage from joystick X over and over, and we'll do joystick Y. That'll be a voltage that will print out though. Dot read. So this will just be a count value. So we'll read the voltage from the X and the count value from the Y. And you can see 2.5 because it's in neutral position. Can move it around. So move the X over here, you get 5. Over here, you get 0. And then click it, it should end, because when the select button gets hit, it ends. So pretty easy. That covers analog in. So I guess the only thing left would be analog out. That's pretty straightforward too. I'll just do it real quick because it's easy. We can do a voltage out like this. We can say V out equals let's say VDAX 0, so we'll use our voltage DAX. And then to kind of see what's happening, we'll make a V in. So I just connected the output of this DAC to the input of a analog pin, so I can just make another analog pin just like that. And then we can say, let's start our V out, and now we can do set of voltage. So we've got a number of different things you can use here. Let's use set voltage. Let's give it a voltage of 1. So now this should make the analog output 1 volt. And then when we read from V in, we should see that it says about 1 volt. And it does. It says exactly 1 volt. So you can play around with that. The one that I have set up, I purposely set it up to only be go up to 1.02 volts. So if I tried to do like 1.5 volts, because I set it up this way, it won't actually let me do it. It'll say, when I try to read it in, it'll only go up to 1.02. This just gives me higher resolution, basically. So, but I could do like 0.8, and now that should read in pretty close to 0.8, 0.81. So, yeah, generally that's the idea. Voltage out's pretty easy if you ever need to use it.